Welcome back from the break. As promised, we're going to show you how to tune an AFR sensor equipped vehicle using the 3X optimizer. Sound exciting?
Yeah.
Step number 1. The wires designated for the O2 circuit you do not use. We're not going to tune the AFR with any part of the 3X optimizer. AFR sensor
First thing we do is eliminate the side cutter. Or just roll them in about one page. How much less than the sheet? $5.
will be drawn in a schematic, something like this. You got your heater wires, and on the actual sensor, not necessarily the vehicle wiring, but on the actual sensor, the heater wires will be white and white. No, I take that back. I hope you're using pencil.
No, that's okay.
They will be black.
You're drawing a traditional O2, right?
No, I'm not. I'm drawing an AFR. So your heater wires are going to be black and black. Traditional is white and white, which is why I screwed it up. Your reference wire will be white. And your signal wire will be blue. This is on the sensor itself. Once you get past the connector into the vehicle harness, those colors could be anything, depending on who made it. But on the sensor itself, black, relatively small gauge wire, like a 20 gauge wire, and then the white and the blue will be a little bit thicker, 16 or 18 gauge. Whereas a traditional oxygen sensor works off of creating voltage. And the lack of oxygen's not really a poison, but it's an inhibitor to the generation of voltage. So when you have lots and lots of oxygen, you cannot create voltage from a traditional sensor. In an environment relatively free of oxygen, that oxygen sensor can produce voltage. It's all a voltage game. If you look at an AFR on an 03 Toyota Camry, your white wire will always have 3.00 volts. It will never, ever deviate from 3.00 volts. The blue signal wire will have 3.30 volts and never deviate from 3.30 volts. You watch your scan gauge on that Toyota and it's talking about 1 point something volts up above 5 volts. You go in here with the voltmeter and you got 3 and 3.3 volts. Scan gauge, I mean, you do a snap throttle, pull vacuum lines, propane enrichment, the numbers on the scanner are all over the place. The numbers here will never deviate from 3 and 3.3 volts. It is an amperage regulated, or a voltage regulated, amperage varying type of a sensor. Now you get Dennis's Honda on a scan gauge, and Honda gave us more credit for being intelligent than Toyota did, because Honda will show you under O2 signal varying amperage in milliamps. Toyota figured we were all dummies. We're so used to voltage signals that that's all we can understand, that if they actually told us the truth and showed amperage on here, we would be so confused we wouldn't be able to fix their cars. So Toyota takes that amperage signal and converts it into a voltage reading on the scan tool. But that Toyota will have 3 volts and 3.3 volts no matter what. Well, Dennis's Honda has fixed voltages also. But at least the scan tool shows varying amperage. A lean mixture has a high flow of amperage. The resistance in here goes down. A rich mixture has a low flow of amperage. The resistance value goes up. The old mass airflow sensors, well, old, new, whatever, they have a heater wire in there, and then they have a little temperature sensor in there. The computer will vary how many watts of power they put to that heating element to maintain a fixed temperature. If you look at the temperature coming off the mass air, no matter whether it's idle or wide open throttle at max red line, that temperature is always the same. The ECM will start throwing more and more power to that wire to maintain the temperature. Now, how much air is going into the engine? Well, the more air that goes in, the harder it is, the more power it takes to keep that high temperature, because the air flowing past that wire tends to cool it back down. If you have a fixed 3 volts and a fixed 3.3 volts here, then as the resistance in the circuit changes, the computer can say, well, we have a lean mixture. It's like a dead short. We're flowing a lot of current through it. If we have a rich mixture, we're hardly flowing any current at all because the resistance value is so high. So there's 2 elements in the ECU that are involved in this process. One, it's sending out a reference and it's sending out a signal, and it's going to vary the amperage to maintain those 2 voltages. If you want to lean out an AFR, put a resistor in that blue wire. That will lean it out. Putting a resistor in that blue wire will create a rich signal to the ECU. What we've done is we've basically offset the signal. 4X is going to be a little bit more sophisticated than this, but to get you guys functional on AFRs, this will work.
What value do we start with?
The range. Somewhere between 10 and 30 ohms is where you'll most likely wind up. (20 ohms being a common value. Notice that does not say 10 to 30 K. It says 10 to 30 ohms. The optimizer, the 4X optimizer, is going to, you're going to be able to adjust it with the ammo box. Okay? The ammo box. And every time you press arrow up or arrow down, you're going to be changing this resistance value by approximately 1/2 of 1 ohm. The resolution of the 4X optimizer is going to be in 1/2 ohm increments.
Box come with the kit?
Pardon?
Box come with the kit?
Absolutely not. This is only available to those people who are certified installers or higher.
Available as in?
Not even available through your distributor. They are available through Dutchman Enterprises only.
Are they available yet?
No. No, the 4X and the ammo box are a simultaneous release. The ammo box does not work on the 3X optimizers. Don't need it till we get the 4X. The 4X doesn't work at all without an ammo box.
What it cost?
I don't know that yet. We're trying to keep it like $100 or less, but we'll see. It's not going to be a $3 grand piece.
Well, that's 124 right there, that's what I was asking.
Yeah, I mean, we're going to try to keep the cost as low. It's not going to be one of those things we make a profit on.
Yeah.
It's just cover the cost, get you guys functional, but we need to regulate who gets them. Because if you think you can screw a car up with a 3X optimizer, you ain't seen a screwed up car till you've seen one with the 4X optimizer fiddled with someone who doesn't know what they're doing. We put a lot wider parameters in. The controllability with the 4X, enhanced capabilities galore. You can really, really screw up a car with the 4X. So that's why these are only going to be available to those that we trust, those who are certified.
Do they have a factory reset? The 4Xs?
The 4Xs, okay, the 4Xs out of the box are going to be shipped to where properly installed, properly wired up, they're still invisible. Remember we said that the digital pots are going to be 50K ohms instead of 10K ohms. At 50K ohms, that's almost invisible to practically everything on the road. The 4X will be programmed to go about 2 steps and stop. You need to go in with the ammo box and tell it to go a lot further so it actually has an effect on the vehicle. The 3X circuit for controlling the typical oxygen sensor will be duplicated with very few changes on the 4X. That little graph that's in the training manual where the oxygen sensor voltage goes up and the optimizer voltage steps will be what the 4X does also when you select standard oxygen sensor. But instead of a 0.16 volt switch point, it's being shipped with the 0.50 switch point. In other words, you get it hooked up right, and we're just doing the same thing that the computer does, except we're doing it before it gets to the computer. It doesn't lean out or enrich. It's invisible. The AFR portion of the 4X will be shipped with this value, I think 2.68 ohms. Negligible. Have almost no effect on the circuit whatsoever. The wideband, which I'm going to cover here shortly, will be shipped practically a dead short, so it has no effect on the circuit whatsoever. So until you go and get it tuned, you're not going to get the mileage gains. And you're not going to try tuning it yourself. You're going to go to someone who's competent to get that part of it done. What do we have riding on it? Why is it so important? Because we're guaranteeing we're going to give you your full retail back if you don't get the 50% gain. But we're not even going to offer that unless you've taken it and had it tuned. You buy the kit, you get what you get. You have it tuned, we guarantee you at least 50% increase. But by shipping the optimizer practically invisible, we're not getting check engine codes. We're not going to get somebody who doesn't know what the heck they're doing getting us shut down by EPA.
By the what?
Environmental Protection Agency. As long as we're EPA compliant, they don't really have a leg to stand on. But if they can get 50 or 100 cars out there that are tripping check engine lights and increasing pollution because someone who had no idea what the heck they're doing went in and just totally screwed everything up, then they can challenge us in court. So you can start out with a potentiometer, like a 50 ohm multi-turn pot. Drive the vehicle. Just keep leaning it out. Multi-turn pot, of course, would be better than a 3/4 turn pot. And just keep adding resistance, and you tune it the same way you would a 3X optimizer. Turn your knob. When you got it where you want it, take your ohm meter across and see what resistance value you landed on. Put a fixed resistor in there. Any questions on tuning a 4X? Yes, sir.
Just a general question about the AFR here. I'm not sure whether my vehicle has an AFR in it or not, but it's oscillating between 2.5 and 3.4 volts.
Then you have probably a fairly late model Dodge.
Yep,
Okay, that's something
that's the
different.
cruiser.
That's something different.
Still say on the white sticker, no, if there's an AFR in it?
Not always.
No.
Not always. We've not found a cut and dry, foolproof way of determining, because black, white, blue, most of the time is an AFR, but guess what? We've seen ones that respond beautifully to the 3X optimizer. They act like an old style oxygen sensor. The 3X optimizer works on them just like they were an old style oxygen sensor, but they got black, white, blue. It's befuddling. This works the same, no matter what vehicle it's on. It varies a resistive value. Now, what the ECU does with this resistive value does vary from vehicle to vehicle. Toyota is going to put 3 volts and 3.3 volts on there, and Toyota then will vary the amperage going through this circuit to maintain 3 and 3.3 volts. There are other vehicles that are going to put a fixed amperage on here, and then they're going to monitor a change in voltage. So the computer has to have one of the two fixed, either amps or volts. If it fixes the amps, then the volts are going to vary. If it fixes the volts, the amps are going to vary. Either way, it is a resistive circuit. Either way, that is going to give you the tunability you need. Any more questions on AFRs before we move on to widebands? Everybody got this? All right. A wideband is a very versatile oxygen content measuring device. The narrowband oxygen sensor has been around since that I know of 81, I suspect as far back as 79. Has a very small range. It's like 14.2 to 15.2 or 15.3 to 1 air-fuel ratio. Very narrow band. Once you get above or below that range, then the sensor itself is so sensitive that it's almost impossible to get half-decent measurements off of it. The AFR sensor is, I call it, an extended range sensor. It has a wider range than the narrow band, but it's not the wide band. A wide band will go from a 10-to-1 air-fuel ratio to atmosphere. Very wide range. You look at a wide band, and the Mazda sitting out by the road with the 121 mile per gallon sign on the door has a 5-wire wideband sensor. On the list of vehicles scheduled to show up today is an 08 Mazda that may have a 5-wire wideband sensor on it. I believe from memory the blue wire is your signal. At a 14.7 to 1 air-fuel ratio, that's approximately 3.2 volts. The wideband operates from 0 to 5 volts DC. And it's linear. As the air-fuel ratio changes, the voltage changes evenly. The narrow band, the curve looks kind of like this. The wide band, you can practically put a ruler on it. 14.7 then would be like right about here. There's quite a few variations of this on the internet, but it's called an EFI, Electronic Fuel Injection Enhancer. Originally developed by a guy named George Weissman 20-some years ago. They were designed to work on the narrowband sensors, very, very limited capability on what it was designed to work on, but it happens to be a pretty good circuit for the widebands. They run about 60 bucks from I think it's www.better-mpg.com. They have, for the same price that Eagle Research charges for a single EFI, they have what they call the double EFI. So a V8 engine with twin widebands, that $160 EFI will do both sides. This is an improved version over what GW's been doing, Eagle Research. The Eagle Research version has an issue where it takes a 555 timer, takes battery voltage, turns it into a pulsing DC square wave, then attempts to take that square wave across a one-to-one transformer. And transformers don't like square waves. A transformer is designed to pump a sine wave. And so when you put that square wave across that transformer, you burn them out. I built 3 of George Weissman's, burned out 3 transformers, gave up on it, thought I was just buying cheap transformers. And then when I talked to our electronics guy, he said, no, you don't put a square wave across a oh, no wonder you were burning them out. Oh. The 4X design is going to accomplish the same thing with radically different circuitry. What are we accomplishing? We want to essentially, we got our sensor here, and ECU here. Ideally, what we would do, we'd cut this signal wire, and right here, put a battery. Because this battery's negative side is in no way tied to the vehicle's ground system. This battery's plus side is still in no way tied in with the vehicle's electrical system. It's a free-floating battery. As this voltage goes up and down, this voltage goes up and down, but at a higher rate. The difference in that rate is the value of this battery. So if you could have a battery that had a little adjuster on the side where you could increase or decrease the voltage, you could tune a wideband perfectly. Because you add voltage to that signal wire, remember it's linear, you add voltage to it and you're telling the computer we're richer than we actually are, so that it will lean it out to bring it back to that 3.2 volts again, right? So to create a free-floating battery, we generate an AC signal, run it across a transformer, run it across a diode bridge,
To DC.
and then put it in line. You don't have to know about electronics to be able to purchase the product and wire it up properly. The 4X optimizer, you're going to cut the signal wire, splice in the optimizer leads, and then as you press arrow up, arrow down, you're going to vary the amount of voltage that free-floating battery has. You tune it the same way you would any other oxygen sensor. With the 3X turning a screw, with the 4X playing with the resistor, the wideband, you just vary the millivolts that you put through there. If you are electronic oriented and you want to build your own version of this just to play around, the amount of voltage that you're going to need is going to be 0.3 to 0.6 volts. Not a lot. Any questions on the AFR or the wideband?
This is something you can purchase or something?
Hang on, I got 3 talking at me at one time and I can't hear any one of you because they're running the dyno. So, what was your question?
Where do we purchase that?
What's that website I wrote down? BetterMPG.com?
Okay.
Yeah.
Right here? Yep.
Yep.
Okay.
And what was your question?
Same thing, basically.
And what was your question?
I think you answered it. Until we get the 4X, we gotta purchase that and include the wideband.
Yeah.
Okay.
There's another one, another site, BetterMPG.com has them, and I think you can also get them. I don't remember if there's a hyphen in here or not, but it's mpgsolutions.com. Chances of you getting a wideband, pretty slim, but if you do, either one of those 2 websites should have them available.
What is this that we're asking for or looking for when we go on that site? What do you call that?
What are you asking for or looking for when you go on that site? EFI, electronic fuel injection enhancer. Jerry.
That wideband sensor, years ago when Snap-on came in the shop, they said they got a new sensor out that Nissan and some of the cars are using. And you need a special O2 wrench to get it out.
What did he say?
It was
Electronic
$17.
fuel enhancer.
I bought it, I never used
enhancer,
it.
right?
15 years.
15 years ago? The earliest widebands I'm aware of was 1990, as far as in a factory production vehicle, was 1998. Volkswagen put them on their 1.8 turbos, their GTIs and their Jettas. So the 5-wire wideband, I mean, they may have been out before then, but 98 on the V-dubs was the earliest actual production vehicle that I know of that used one. That's not to say that something else. Yeah, I'm sorry, what'd you say?
Still 22s. 22 millimeter.
Okay, still the same 22 millimeter, okay. Now that I can hear, I saw another hand go up somewhere. So you guys got a handle on this then? Pretty good?
Yeah, electronic fuel.
Injection enhancer.
Enhancer.
Electronic fuel injection enhancer. For that matter, just Google. You'll probably find 10 other people out there selling their versions. They're commonplace. Okay, let's see if Grant's ready yet.